Okay, so let's resume the class. Okay, so we are going to start in this class a new topic called the generating function. So to begin with, so let's take a look at this counting problem. Okay, so we are going to buy what? So we are going to buy apples and oranges. So we're going to buy these two things. Okay, buy home. Okay, these two things. A total. So let's say we are going to buy a total of five things. So the number of apples together with the number of oranges has to be equal to 5. Okay, we want to find out how many ways are there. But then there are some restrictions. Okay, suppose that for some strange reason, the number of apples has to be even. You cannot have a lot of apples. And let's say for a certain reason, the number of oranges has to be between 1 to 4. Okay. So you must buy at least one, but you cannot buy more than 4. Okay, it must be 1 to 4. So how many ways are there? So if we do counting, then we can list out all the different cases. So because, for instance, the apples can be even. So we need to consider the case where we are buying 0 apples, we are buying 2 apples, we are buying 4 apples, we are buying 6 apples. But then after that, we can just ignore. Okay. And for oranges, we need to look at 1 orange, 2 oranges, 3 oranges, and 4 oranges. And then by quickly counting it, there are not many cases. We may be buying 2 apples with 3 oranges, or 4 apples with 1 orange. Is that okay? So these are the cases. But for this problem, let us use a strange math formula to see how to solve this. Okay. So we can use a formula, first of all, that we may be buying 0 apples. So we may be buying, so this is a bag, and it does not have any apples, empty, or, so I'm going to use plus to represent or, we may be buying a bag with 2 apples. Is that okay? Or we may be buying a bag with 4 apples. And let's say we don't know the total number of objects that we are going to buy in the end. We may be trying to list also the case where we are going to buy 6 apples. And so on. So I'm going to use this formula to represent the different ways that we can buy apples. Okay, either 0 apple, 2 apples, 4 apples, 6 apples, 8 apples, and so on and so forth. Is that okay? And similarly for orange, then we will have a formula. Then the orange formula is easy. So we cannot buy no orange. So this is not an option. So we can buy 1 orange. So 1 orange. Or we can buy 2 oranges. And we may be buying 3 oranges. And we may be buying 4 oranges. Is that okay? And that's it. We don't have any more options, because it is either 1 or 2 or 3 or 4. I'm using plus to represent or. Okay. Why I'm using plus? Because or means rule of sum. I can choose this case or that case or that case or that case. Okay. And then for this process that we are going to buy apples and oranges, we are going to select some apples and then select some oranges, right? So this is a process that is going to select apples and select oranges. So what I'm going to do is, I'm going to multiply these two formulas together. This is going to be a very strange formula, but let's multiply them together. So how do we multiply? Well, just use our notation. Okay, this one multiply with this one. So I will have a term like no apple with 1 orange. Is that okay? I will also have, okay, multiply, right? This one multiply with this one is this one multiply with this one. Is that okay? And then plus this one multiply with this one. So we have no apple and then 2 orange. Is that okay? So I will have another case. No apple with 3 oranges. And then I will have, so the formula is going to be very long. No apple with 4 oranges. Okay, and it's not the and, so the formula and this one, and. Okay, and what? And this time, so no apple, we are done. So we are looking at 2 apples with 1 orange. Is that okay? And then, yeah. So let me speed up. So my 2 apples with, okay, 2 oranges. And then 2 apples with 3 oranges. And so on and so forth. Okay. Okay. So it's going to be infinitely many number of terms, right? Because the number of apples is just even. So it can be 0, 2, 4, 8, 10, up to infinity. Okay? And what is so special about this formula? Okay, this formula actually lists out all the possible cases that we can have. And then, what was our target? Our target is to get 5 objects in total. So what should we do to answer the question, how many different ways that we are going to buy even number of even number of apples, 1 to 4 oranges, such that the total is equal to 5. So we look at all the possible cases and find out, oh, this is a case. This is a case that the total is equal to 5. Is that okay? And then somehow later, we find a case that we have 4 apples and 1 orange. So we find another case that the total is also equal to 5, so that we conclude that these are the 2 and then no more. And then so we can conclude that these are the 2 ways that we can buy apples and orange in what we want, in the form that we want. Okay? But so this formula is super powerful. This is super powerful because it captures all the possible cases. But then somehow this is a very difficult to handle. The reason is that what? The reason is that we need to scan a lot and then, oh, somehow I find here and somehow I find there, right? So for each case, I need to count. Okay, this is just 4 objects, so this is not what we want. This has 3 objects, this is not what we want. So it takes some time to do so. So let's do an improvement for this one. We are still trying to solve the same counting problem, but we are going to do a little bit of improvement. Okay, so here, in the case of no apple, I'm going to just write no apples. Okay, in the case of 2 apples, I'm going to write down x squared to multiply with this. This x is something called, we call it an indicator. So it's nothing special, the square here means that I have 2 apples. Is that okay? And then I will have another term. So when there are 4 apples, I'm going to multiply this with the term x to the power 4. Is that okay? X to the power 4. And then for the case with 6 apples, I'm going to multiply this with x to the power 6. And so on and so forth. We keep it the same thing, but I'm multiplying each term by x to the power, the number of objects in that term. Is that okay? And then in case of the oranges, then the formula will become what? The formula will become, in case of having 1 orange, I'm going to multiply this with x. Is that okay? And then in case of there are 2 oranges, I'm going to multiply this with x squared. Is that okay? And then in case of 3 oranges, I'm going to multiply this with x to the power 3. And for the case where we have 4 oranges, I'm going to multiply this with x to the power 4. X to the power 4. Is that okay? Is that okay? So far so good, right? If I have this change, then what will happen to the term that we are going to multiply? So I'm going to be lazy because the terms will be very similar to what we are looking at here. So instead of having no apple, 1 orange, we will be having no apple times 1 orange times x. Is that okay? So we will have an x here. Is that okay? Instead of no apple, 2 orange, we will have no apple, 2 orange times x squared. Is that okay? So we have an x squared here. This one, we have an x cubed here. This one, we have an x4 here. Is that okay? And how about this one? X to the power what? 3. Is that okay? Because 2x comes from this apple and 1x comes from this orange. This is going to be x to the power 4. This is going to be x to the power 5. And this also has x to the power 5. And suddenly it is becoming not as messy as before. So to get the case where we want to have a total of 5 objects, what should we do? We look at the terms that are going to multiply with x to the power 5. And those are the terms that we want. Is that okay? So far, if you understand what I'm talking so far, could you please raise your hand? Okay. Now, let's do something, one more step, which is much cleverer. Okay, if you understand this, we can suddenly make it even simpler. So what we are going to do, remember, I'm not asking you to list out all the possible ways to buy 5 objects. I'm asking you how many ways are there. So I want to get the magic number 2. Rather than, 2 apples and 3 oranges, and then the other case is 4 apples and 1 orange. I don't need to know what are the specific cases. I just want to know how many ways are there. So I want to get the magic number 2. So is there a good way to get the magic number 2? So somehow, I just don't need this. For this one, if you tell me the value 1, this is representing one way. And for this one, if you tell me the value 1, which represents another way, what I need to know is 1 plus 1 is equal to 2. I just need this 2. So is there a good way to do this? So let's take a look of how many ways are there. We can have a total of 2 objects. 2 objects? Okay. You find that this is the case that we are interested because it is x squared. So this constitutes 1 here. So there is one way of having 2 objects. And then, okay, if you examine things carefully, there are no more ways. So for this one, I hope to get a 1 to represent this one. Okay. Is there a good way. I don't need this diagram, right? I just hope that, okay, if I want to get the number of ways that we can have 3 objects in total, okay, so this is one way with 3 objects. And then this is another way with 3 objects. And that's it. So in that case, I just want to have this 1 plus 1. So what is the best way to make it 1? So I don't want this, but I want a 1. I don't want this. I want a 1. I just want a 1. Any idea? Do you have any idea? Anyone? Any idea? Okay, I tell you. Idea is very simple. Just make everything here 1. This shape 1. This thing 1. This thing 1. This thing 1. Because 1 times 1 is 1. Is that okay? So if I want to solve the counting problem, the number of ways, then I don't even need to draw so many things here. So I want to list out, okay, the formula that is representing apples. Okay, so I have one way of choosing no apples, and then I have one way of choosing 2 apples. Is that okay? And then I have one way of choosing 4 apples. I have one way of choosing 6 apples, and so on and so forth. And then in that case, I'm going to use this formula to represent apples. Okay, and then for orange, what is the formula? The formula for orange will be equal to 1 times x plus 1 times x squared plus 1 times x cubed plus 1 times x to the power 4. Is that okay? And then if you expand this thing, okay, then we will get something like it is equal to how many? So it is going to be equal to 1 times x plus 1 times x squared plus 2 times x cubed plus how many times x4? So to get x4, you can have 2 to get x4, right? You can have 0 and 4 to get x4. And that's the case. So it is 2 times x4, and then we can have 2 times x5. x5 we just did it, and then plus how many ways to get x6? x6 is 1, 2. Is it? No. This one you cannot get x6 because we have the maximum of x4. So we can actually write it here. How many ways to get x6? It is going to be 2. 2 match with 4. 4 match with 2. 2 x6. Yeah, let's do a few more times. How many x7? x7 you have 4 and 3, 6 and 1. Also 2? Always 2? It looks like always 2. Whatever. Okay? Okay. Now, this is the so-called generating function. Everything here, they are generating function. So what is a generating function? Generating function is a kind of so let's say fx is a function of x. And then it is a generating function means what? Means that we don't care about what is the value of this x, but we care about the polynomial after you expand this fx. What are the coefficients? The coefficients are what we want. So here, this is a generating function such that the term, so if you look at suppose that ci is the coefficient of xi in this formula. Let's say this formula is just, let's call this fx. In fx, then ci will be equal to the number of ways to buy a total of I apples and oranges as we required. Is that okay? Okay. So by having this is a very good way to represent terms that we want. So we know what? There is zero way, zero ways to buy zero things. Yeah, that's true because we need to buy at least one orange, right? There is just exactly one way to buy one item. There is just exactly one way to buy two items. There is just exactly two ways to buy three items, and so on and so forth. Is that okay? That's interesting, right? So not just this part is a generating function, but this part is also a generating function. So you can call this part, the red part, let's call it gx. Okay. What is the coefficient? The coefficient of gx is what? It is telling us that the number of ways to pick apples. The coefficient of x squared is the number of ways to pick 2 apples. The number of ways to pick 4 apples, one way. Okay. The number of ways to pick 6 apples. Is that okay? And this is another function, hx. So it is the number of ways to pick oranges. Is that okay? So it is very handy. Okay. So you can see that, okay, if fx is equal to gx times hx, what does it mean? It is just like we are doing something like a rule of product. We are going to do a task that involves selection of two things at the same time. We need to select apples and we need to select oranges. Okay, the number of ways to select apples and oranges such that apples, you know how many ways are there, what different types of ways that we can do, and oranges, we know also what are the different ways that we can pick oranges, so that the multiplier is the number of ways to pick apples and oranges together. Is that okay? Okay. Okay, good. So we are going to examine, okay, so this is actually the concept of generating function. And then we are going to use it to apply it to solve what? To solve some of the counting problems that we have encountered before. Okay, so let's see. Okay. Okay, so how about this? So suppose that, okay, so what do we have? So first of all, let's take a look of what is the meaning of 1 plus x if you treat it as a generating function. 1 plus x. So 1 plus x is what? So you just have one function, right? So it is about selection of one type of things. Let's call it apple. So what is meant by 1 and what is meant by x? So there is one way of selecting no apples and one way of selecting one apple. Is that okay? So it means what? It means select or not select. Okay? And then let's have 1 plus x. Let's try to multiply this with 1 plus x again. So if the first 1 plus x, let's say it is about apple, and then the other 1 plus x is about oranges, then the multiplication of them would describe what? The number of ways to select apples and oranges. Is that okay? And then if we expand this together, what do we have? If we expand this together, we get what? We get 1 plus 2x plus x squared, right? So what does it mean? It means that if we can pick or not pick apple, we can pick or not pick orange, then there is one way of picking nothing. There are two ways of picking exactly one thing, and there are one way to pick two things. Is that okay? How about this one? How about 1 plus x to the power n? How should we interpret this generating function. How should we interpret this generating function? So it is going to be 1 plus x times 1 plus x times 1 plus x times 1 plus x, and so on and so forth, right? So it is going to be corresponding to what? We have n different types of things. Okay? For each type, we can select or not select, select or not select, select or not select. And then this process will tell us how many ways that we can select. Okay? And then if we expand it, let's see if it makes sense or not. So if we expand it, what do we have? We will have, this is going to be 1 plus n choose 1 x plus n choose 2 x squared plus dot 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 up to n choose n x to the power n, right? This is exactly what we have done. Because there are going to be exactly n choose 1 way of picking one thing. There are exactly n choose 2 ways of picking 2 things. Exactly n choose 3 ways of picking 3 things, right? Good. This is good. So as long as you can have a linkage, you understand the meaning of a formula and the formula, then we can use the formula to help us to solve counting problems. So it's still not solving any problem yet, but see. But we will see. We will see soon. Okay. Oh, okay. Now as a sidetrack, okay. As a sidetrack, can you show this? Oh, by the way, this is called what? This is called the binomial theorem. Is that okay? 1 plus x to the power n is called the binomial theorem. We have generalized version of binomial theorem, but this is the integer case. Okay, so how about this one? This is not a counting problem, but this is, oh, you can think of this as a counting problem, okay. What is the value of this one? N choose 0 plus n choose 1 plus n choose 2, what is it? 2 to the power n, right? This is going to be 2 to the power n. Yeah, this is true. Okay, integer n, positive. Why?